we studied integration, we saw how to recover a function from its derivative. That's what is called the process of integration. So you have f prime of x equals to x for square. Then by integrating, you have f of x is equals to x to the 3 over 3 plus constant. There is some level of undefinition, something that is not properly finished, which is this constant here. How do you find the constant? To find the constant, you need more information. So you need what is called an initial condition. And some of the problems have that. We need an initial condition. Initial condition is something that we start the problem. Forget that. Initial condition. So f of 1, for example, equals to, I don't know, like 3. Then if f of 1 is 3, from this formula here, we have f of 1 is 1/3 plus c, that's equals to 3. So c has to be 3 minus 1/3, which is 8/3, and the function f of t equals to x cubed over 3 plus 8/3. So we have done two things. We have done from f prime to f, we have integrated, and we have an indetermination by the integration constant c, and we have an initial condition to determine c. That's what we have seen so far in the fundamental theorem of calculus. Now, in this topic number 3, we're going to do something a little bit more complex, which is we're going to have the data, we're going to have the type of problem we'll have an equation involving a function, say a function which I'm going to write as y and its derivatives. It could be one derivative, it could be more than one derivative. For example, y prime, y second prime, blah, blah, blah. An equation, for example, y double prime plus 3y prime minus 6y equals to something here. Okay, we'll fill this in here, and we're going to have some initial conditions. So, and the goal of this is simply to get a formula for y. Okay, so let me set a few things we need in order to continue. So we are going to, from now onwards, we're going to always have the function. I mean, not always, but most of the time the function is, or the dependent variable is going to be y. And the independent variable is going to be t for time, because it's quite standard to consider t as a function, as a parameter. Like, for example, the way the GDP evolves over time. One may know, for example, y could be, for example, the amount of money in the country, the GDP, and then we know y prime is the rate of change of the GDP. So we may not know that the rate of change is 3, but we may know that the rate of change of the GDP is the square root of the GDP or something like that. Okay, so then we have a function y and an independent variable. So this means y is actually should be y of t. And then we're going to have an equation. That equation will involve t, y, y prime, y second, blah, blah, blah. For example, and I complete the equation above, that we have above, y double prime plus 3y prime minus 6y equals t squared. For example, that's an equation. And we have a set of initial conditions. Okay, like initial conditions can be written, we may have one or many. For example, y of 0 equals 3. This means simply that when t is 0, y is 3. Another type of initial condition we could have, and that's another example, this is one example, and another example of initial condition is y prime of 4 equals to 7. So that means that when t is equals to 7, the derivative of y is equals to 4. And like I said, the goal is to get a formula for y. Consider a very simple case, which is called separation of variables, okay, or separable equations. So first I will do an example, and then we can give to the general rule or the general procedure. So we have this equation given, y prime equals to 6y squared t, and then we have y of 1, the initial condition is y of 1 equals 1 over 25, and we want a formula for y as a formula of t. Okay, so it's standard in this type of notation. Y prime means the derivative of y with respect to t, so it's written like this. So our equation gets written like our equation y prime equals 6y squared t gets written like dy over dt equals to 6y squared t. Now, in this type of equation, we're going to do a technique, which is the separation of variables, which means separate variables. Means everything that has y goes to one place, and everything that has t goes to the other place. Here we go. We move the dt to the other side, and the y squared to this side here. So we have y squared, which is multiplying, will come here dividing with dy, and the dt, which is dividing, will come here multiplying 60 dt. And the next step we do is we integrate both sides. So let me put in red so it's clear. Integrate both sides. And this is separate variables actually. So separate variables means on one side of the equal we have only y, and on the other side we have only x. So integrate both sides. The integral of 1 over y squared dy is the integral of 60 dt. And the integral of 1 over y squared is simply minus 1 over y is equals to the integral of this is 3t squared plus constant. Now let me tell you something about the constant. You have asked what happened with the constant of integration here. Okay, that will be a different separate video that I will upload later in a different video. So once we have done this integration, we have that minus 1 over y is equal to this expression. We almost have the expression of y, we're just missing the value of c, for which we used what we have said before, the initial conditions. The initial condition in this case was saying something like, here you can see y of 1 equals 1 over 25, or if you prefer, this is saying when t is 1, y is 1 over 25. So we replace this in our solution here, and replacing these two values, have minus 1 over 25 equals 3 times 1 squared plus c. This reciprocal minus 25 equals 3 plus c, c equals minus 28. And so we have finally that minus 1 over y is equals to 3t squared minus 28. Taking reciprocals, we have minus y equals 1 over 3t squared minus 28, and we put the minus on the other side and exchange the order of the terms in the denominator, and this is 1 over 28 minus 3t squared. And that's the solution of our differential equation. Recap the method of separation of variables. What we have is a differential equation of degree 1, order 1, because it involves only the first derivative, and it's of this form: f of y times y prime equals g of t, or if you prefer, f of y dy over dt, so moves to the other side, g of t dt. That's the separation of variables, only y here, and here we have only t. And the way to solve it, you integrate both sides. So this becomes the integral of f of y dy equals the integral of g of t dt. And finally the solution will be an expression of y equals to an expression on t, and hopefully you can solve the expression of y. This does not need to be y exactly, could be a formula, but from here you can get y equals y of t on most cases. If you don't get it, it's okay. The question is to have separated y and t.